Good afternoon, Doctor. Today we're going to explain about fuzzy logic mini project, hepatitis C prediction. This is the interim of our project. Basically, we're going to explain about what are we on and what progress have we done so far. So our team consists of 4 people, starting from Kamal, Roshini, Harish, myself, and Ahmed Abdi Muhammad. Okay, so we have our certain roles that we have displayed here. So Kamal will be starting with the data exploration and analysis. So I'll give it to him.
Okay, so for data exploration, we will be doing a project about the prediction of hepatitis C using fuzzy logic approach. So the data set we are using here is hepatitis C prediction data set from Kaggle, and this data has valuable information for analyzing and predicting this disease. Okay, it includes demographic and clinical attributes as well as laboratory test results. Okay, so these things can be used to build a predictive model or gain insight into the factor associated with diagnosis and progression. Okay, so we have discovered around 615 observations from the data on 14 attributes of blood donors and hepatitis C patients, laboratory and demographic values. Okay, so these are a few attributes from the data set. We can see here the age of the patient, the gender, and we can see here it has cholesterol level, albumin, serum test, creatinine, and so on. So these are the things we have explored from the data set. So next I will pass to Roshini.
So for data pre-processing, we have done 3 main procedures before performing classification and clustering. So the main is first is data cleaning, normalization, and then random forest elimination, which is the feature selection. First, we have cleaned the data, but initially for the categories of the hepatitis C are blood donor, suspect blood donor, hepatitis, fibrosis, and cirrhosis is accordingly changed to 1 to 5, which is integer. Next, we also standardize the value for sex, where the male is 1 and female is 2. Then we standardize the missing data in the data set and we have removed it. Thus, the clean data is then loaded to perform normalization and feature selection. The feature selection method we used in this project is random forest elimination, where it involves in evaluating the performance of each feature in the hepatitis C dataset. So we use fit ensemble function with the back method of 50 learners and classification type. The predictor importance with the function is applied to the train model to obtain the importances of the feature. The feature importances are then sorted in descending order and the top K features are selected and the K is set to 9 in this project. Finally, the filter data matrix is created by selecting the columns corresponding to the selected features and the target variable from the normalized data set. That's all from me. Next will be presented by Harish.
So as Roshin said, we will move on to the next part where it's the approach of what we have used to predict and to cluster it. What have we done? So we are using fuzzy C-means clustering and random forest classification as a performance measure test. So fuzzy C-means we have done here is using the set of data set, the updated and the clean one. So as Roshin said, we have features, we have selected 9 features, the optimal features that actually makes a change in the clusters. So we have selected 9, and as Roshin said, we have selected so from 3 to 9. So basically from 3 to 9. As per my concern, it starts from ALB, the albumin blood test, until the creatinine. So what I've done is the basic formula or the how it works is we take up a lot of points, which is 600 points just now, 600 data, rows of data. We take every column in 615 of the sets, and then we find the distance between each other. So basically, the shortest distance between the center and the particular data point denotes where it sits. For example, if there's a data set which has a Euclidean distance of 100, it stays far 100 units from the center. And if another point has a center distance of 10, it is closer compared to the other one just now. So we have clustered using the centers and the U. As you can see on the right side of the screen, I have labeled the coding. We can see centers and U. So we have used FCM module to use the filter data with the value of K. The K refers to number of classes, which is number 3. So you can ask, why did we choose K is 3? So basically, based on our own observation, and we have done certain assessment using elbow method and the K-means method, we have found that 3 is the best. So, and then we have used the 2.0 for the fuzziness, 1000 iterations, and the exponent factor of 10 on exponent to the -10. And then we have done iterations of 1000 iterations for 600 data set. So basically, if we see the data is going to be like this, going to be scattered like this. As you can see, there's 3 centroids because we have 3 main classes. So cluster 1, cluster 2, cluster 3. So as you can see, we have the star, which is centroid of each, and you can see the plot, the classes are scattered everywhere, but in a decent correction behavior. So basically, this is how it works, and we can see there's 3 legends here, mainly hepatitis, cirrhosis, and fibrosis. So that's all from me. More of it will be centered and given by Ahmed.
Okay, for the last week, and we want to continue the prediction of clustering. As you can see in the graph, we have 3 classes: hypothesis and cirrhosis and fibrosis, and each one represent for the FCM clustering result. And the right side for the you can see the input value of the specific the input value for the prediction, and as you can see, the membership value is the output of the values, and belong in cluster 3, and we have accuracy, specificity, and sensitivity and precision belongs to cluster 3, and the last one is the average of coefficient and how the FCM clustering developed. It is 0.213594. Thank you very much.
Thank you, Doctor, for spending your time to watch our interim.